Howdy, howdy, this is Mr. Potter. Today we're going to be talking about permissions and attributes. So I'm actually going to start by doing an ls command, but I'm going to do a hyphen and an L. And this actually gives us a long listing. And the whole idea behind this is that it tells us a lot of things about this. You'll notice this group here has a hyphen, RW hyphen, R hyphen hyphen, R hyphen hyphen. This first group of letters here actually tells us what we can do. And there's actually 4 different letters that we will see here. If I had the full listing of letters, I would see a D, which stands for directory, RWX, which stands for read, write, and execute. And then I'll see another RWX, RWX. And those letters actually depend on the who. So the fact that it's a directory notwithstanding, this first group here, this first R, W, and X, stands for the user. In other words, me in this case. I'm the one who owns this file. I can, in the case of this file, I can read and write this file. I can't execute it because notice it's a CPP file. It's a source code file. It's not a compiled file. And we're going to compile it in just a moment. The second group, R, W, and X, stands for a group. And in Linux, one of the things you can do is you can assign a user to one or more groups. And everyone in the group has a certain set of abilities, actions, permissions that they can do to files. Now, in the case of this particular file, executed.cpp, I am the user and I am also the group. But what you'll often see in Linux environments is a lot of different groups, and I'll show examples of those in a few minutes. This third group of R, W, and X stands for the other group. In other words, everyone who's not the owner of the file or the group that the file is attached to. And so when we're dealing with permissions, we will often see U, G, and O to represent the user, the group, and the others. And sometimes we'll even see an A. So before we go too far into this, what I want to do is I want to go up a directory, and I want to do the same ls-l, and you'll see something different here. Notice, of course, I've got my episodes 1, 2, 3, 4, and 5 folders, and they all start with a D, which means that they are directories. Notice that I have read, write, and execute ability on this directory. Execute meaning that I can do things to it. In other words, make it work like it's a directory. I can go inside of it. I've got R-X for the group, which means anyone who's in the group but not the owner, they can only read and go into it. They can't write to it. And I've got the other, which can only read and execute. Now what I'm going to do is I'm going to change to a completely different folder. I'm going to go into the var folder because the var folder often holds logs. It'll hold the mail spool. So if your computer has an email server, it will hold all of the emails on there. And obviously there's a lot of privacy that needs to go on in this section. So the permissions here are a very good thing to look at. So if I do an ls-l, you'll see several things here. You will see root, basically the owner of the system, is the one who owns all of these. And root is the only one who is the group. But here you've got staff. And this, in other words, if I belong to staff, then I'm going to be able to do things with this with this group permissions. I can read, write, and do other things as well. syslog is the group for here. Mail is the group for here. And if I belong to either of those groups, I could do things to these. The other thing that you notice over here is you'll see an L, and this L stands for a link. This folder actually connects to another folder, and we'll talk about linking files later on. If I try and go into one of these folders, let's say I try and go into the mail folder, I can do ls, and there's nothing in here. If I do ls with a -l, I see nothing in here. In other words, I'm not going to be able to see anything here. I definitely don't have write ability here. So this is part of the security that we'll see. Sometimes this R will be turned off and I won't be able to read anything. And sometimes, if I go back to my root directory, Actually, let me go to my workspace. If I go into one of these folders, let's say I go into the episode 1 folder, I can go in here and I can see all the files that we talked about in our first episode. But if I change the properties here by using chmod, and I take away execute on episode 1, now if I do my LSL, you'll notice that the episode 1 folder no longer has these X's, and I can't change into that folder. Permissions denied, even though I, as Ubuntu, am the owner of that file. I have the ability to read and write, but I don't have the ability to execute. I can chmod back and add executable to EP1. And now, if I do ls-l, I can see that everyone has the ability to access this folder, and I can change the episode 1 folder and do things to it. So in other words, I can add or remove readability, writability, executability to each of these files or folders. But if I just use the -x, or if I use the +x, that does it for everybody. Maybe I don't want to do it for everybody. Maybe I just want to do it for someone. So if I wanted to do something like that, I would do chmod, and I would give it a group. I would tell others -x to the episode 1 folder. And now if I do that ls-l, notice that the user can still execute, the group can still execute, but other can't execute. So if I'm not the user and I'm not in the group, then I can't get into that folder. So remember, as I said, that we have user, we have group, we have other, and I can either plus or minus read, write, and execute for any of these levels. And this gives me a lot of granularity, a lot of fineness that I can do this to. What's also important to note is that I can use the binary system to change these properties. And for our purposes, read is 4, write is 2, and execute is 1. So I can go back to this episode 1 and say, okay, I'm going to chmod, and I'm going to put a 0, 7, 4, 5. And what this is going to do, keep in mind 7 is 4 plus 2 plus 1, that's read, write, and execute. 4 is only read, which means my group will only be able to read. And if I change this to a 3, just to make things interesting, this group will only be able to write and execute, they won't be able to read. So if I change episode 1 to these permissions, and now list them, you'll notice what I did. The 7 means the user can read, write, and execute. The 4 means the group can only read. And the 3 means that the others can only write and execute. In other words, the properties really have been changed. So what I'm going to do is I'm going to change this back to 755, which is what I usually have for my folders. I want to go into my episode 5 folder, and I want to take a look at what we've got here. Keep in mind that we've got our executed.cpp, and if I cat this file, if I cat executed.cpp, that's going to list everything in here. Notice it's a very simple program. It's got include IOStream using namespace standard, and it's just going to see out I executed successfully and a new line. If I list it with an L, then I'm going to see that I have the ability to read and write. I can't execute it. Others can only read it. If I compile it, now that I've compiled it, you'll see that the file that I just created, this executable file, has the execute bit set for others, the group, and myself. And if I try and run this file, you'll see that I executed successfully. If I chmod it and I get rid of those bits, Now when I ls-l, notice that it's not executable. And if I try and execute it, it's going to tell me permission denied. I can even chmod my executed.cpp. And let me actually give it a flag to take away. I want to take away the read flag. And now no one can read this file. And so if I try and cat executed.cpp, I can't read it. Permission is denied. So we have this ability to change whether or not a user can read or write or execute any file with an amazing amount of granularity. Now, let's say that I don't want to do this file. Let's say that I don't want to have access to this file anymore. I can actually change ownership to someone else. Now, as a local user, I don't have that ability, but I'm going to do sudo. And sudo will allow me to do things as the superuser. So I'm going to sudo su, which allows me to change to the superuser. And notice that I am the superuser now. I am root. So what I can do now is if I do ls-l, it's going to do a listing of all those files. I can chmod my file back to 644, basically returning it back to the way it was. And what I can do now is I can do CHOwn, and I can change the file from being Ubuntu's file to being root's file. And what that means now is that Ubuntu is not the owner of the file. One thing you'll notice, though, is that Ubuntu is still the group. CHOwn doesn't change the group, it only changes the user. So if I exit, so now I'm back to being myself again. If I do an ls-l, I notice that root is the owner of executed. So if I try to edit executed.cpp, notice down here it says read only. And it says read only because I am not the owner of it. All I am is in this group, and therefore all I can do is read. I no longer have that ability to write. I can change the ownership back to this, to Ubuntu executed.cpp. And now if I do ls-l again, now I am back in control of this file. And now if I try and edit, I am back in control. I can change things. So let me change this to I executed unsuccessfully. And we will write and quit. And what you'll notice is that that file was modified today, just a few minutes ago. So I have the ability to change ownership. I have the ability to change the modify the permissions. I also have the ability to change the group. So let me do this. I'm going to do sudo chgrp, and I want to change the group of executed.cpp to the root group. So now if I do ls-l, you'll notice that the group for executed has changed to root. Now, sudo is a very powerful command, so you don't want to use it a lot. There are certain situations where you have no choice but to use it because you can't do anything unless you are the super user, unless you are the owner of the system. Just be careful with it. It's very dangerous. So we have the ability to change, modify the permissions. We have the ability to change ownership, and we have the ability to change groups. So if I want to know what groups I belong to, I just ask the computer groups and my username, and it's going to tell me what groups I belong to. I belong to the Ubuntu group, which is my own group. I belong to the sudo group, which is the ability to run the sudo command to be able to act as root, and also another group called rbm, which we'll talk about later. All right, so I had to pause the recording there for a second. I've gotten us back to where all of our files are owned and grouped to ourselves. The last thing that I want to talk about today is the idea of a umask. Now, whenever I create a file, it has a generic set of permissions that are given to it. So right now, the way I've got it set up is that whenever I create a file, remember how we talked about 4 was read, 2 was write, and 1 was execute. These are the attributes, the permissions that I'm not giving a particular file. In other words, I'm not going to give the write permission to people in the group or people other by default. Now I can change this, but I want to show as an example, I'm going to use the touch command. Now the idea behind touch is that this is going to create an empty file for us. And all I'm really interested in is what the attributes are. So if I do touch and I say foo, then I now have a file called foo. And if I take a look at it, notice that it doesn't have the write attribute. It doesn't have the write attribute for groups. It doesn't have the write attribute for other. If I change my umask, and I change it to, let's say, 0377, what this is going to do is it's going to make sure that I don't give 7 read, write, and execute to groups. I don't give 7 read, write, and execute to others. And I don't give write or execute to myself. So now if I do touch bar, and I take a look at that file, notice bar doesn't have read, write, and execute for all others. It doesn't have read, write, and execute for the group. And it only has read for myself. I don't have the write or execute part. If I do umask 000, and then I do touch bat, now when I list those files, notice that bat has read and write for everything. And of course, execute is a special field. I need to actually make an executable file for this. There's no way that an empty file would ever be executable. Now, if the numbers are confusing, what we can do is we can do umask with a -s, a capital S, and it'll tell me what properties I'm giving all of the files that I'm doing. So right now, because my last umask command was 000, I'm giving users, groups, and others the ability to read, write, and execute. If I change my umask back to the 0377 that I had earlier up here, if I do that and then I do umask -s, then it tells me that I'm giving users the ability to read, groups can do nothing, and others can do nothing. The Linux permission system is very robust and it's very fine. You can do all sorts of levels, but what really matters when you're dealing with permissions is who gets to do something and what they get to do. So we talked about how to change the owner. We talked about how to change the group. We talked about how to change the permissions using chmod. We talked about how to run commands as the superuser using sudo, and how to change to the superuser by doing sudo su. We also talked about the dangers of running as root, so please don't do that unless you absolutely have to. And we also talked about the umask command, which allows us to kind of set our default, how the files that we create are created with what permissions. So once again, this is Mr. Potter. Thank you for watching. Have a great day.